Okay, gang, so this is my first video for your class. So this is a lesson on 6.5. Let me get it right here. So a lesson on 6.5, which is titled Linear Inequalities. Okay, and so that's what we're going to talk about today is linear inequalities. And I'm sure you've heard of the 4 inequality symbols. And they are less than. And when we flip it, it will be greater than. But then over here on the other side, if I go like that with the line under it, this is less than or equal to. And then finally we have greater than or equal to. And so those are our 4 inequality symbols, gang, or equal to. And now before we left for break, you were solving equations. And so you're going to solve inequalities the exact same way. So let me give you one big note. We solve linear inequalities the same way we solve linear equations. However, gang, there is one exception. There is one exception, and here it is. When multiplying or dividing by a negative, guys, it has to be a negative number, okay, by a negative number, and you may or may not remember this, you must flip the inequality symbol. Okay, and so I am just going to go into some examples. And so I'm going to try to pull examples from the actual PowerPoint that I gave you online that I also hope that you have looked at. So, but I'll probably give you a couple of extra just in case. So I'm going to start with the example that I gave you. So the example in the notes, or the example on the PowerPoint says this: negative 6x is less than 18. Okay, so when we say negative 6x is less than 18, we really mean negative 6 times x is less than negative 18. And so I know that you know we would divide both sides by negative 6, divide both sides by negative 6. Negative 6 divided by negative 6 is 1, so that we cancel this out and we get x. But slow down, because you literally just divided by a negative 6. And right here where I'm underlining, it says if you divide by a negative, you must flip the inequality symbol. So this less than is simply going to become a greater than, and 18 divided by negative 6 we all know is negative 3. And so let me pause, because the directions, and I should have wrote them earlier, the directions will say solve, which we just did, we solved, but it will also say in graph. And so now we need to graph this inequality. So I'm going to draw a number line. Okay, nothing fancy. I'm going to put negative 3 in the middle because that's the number I'm looking at. And to the left of negative 3 is negative 4, and then negative 5. And to the right of negative 3 is negative 2 and negative 1. Okay, so there is a little bit of a number line. And now we have to graph it. So x is greater than negative 3. Well, I think we all agree that these numbers over here are greater than negative 3. Negative 2 is greater than negative 3. Negative 1 is greater than negative 3. So we're going to draw a line, and we're going to put an arrow because all of the numbers in this direction are going to be greater than negative 3. However, the thing is, we have to know if we're going to put an open or closed circle. Well, it says x is greater than negative 3, which means we cannot be negative 3. We have to be bigger than negative 3. So we're going to draw an open circle here, okay? And so if I go back up here and give you some additional notes, if you have less than or greater than, for those of you that like to keep it simple, when graphing, you will graph an open circle if it is less than or greater than. And if we come on this side, when we have less than or equal to and greater than or equal to, when graphing, we will graph a closed circle because we're including it. We're including it. It is equal to, so we close in that circle. Okay, so there is one example, and that's the example that they give you in the notes. But personally, I feel like you probably need a couple of more. So let me give you a couple more, and we'll keep this video short. So example 2. Let's solve and graph it again. Solve and graph. Okay, and let's do 3 minus 2x is less than or equal to 11. Okay, so let's get started. So if I wanted to solve this inequality and isolate the x, I would need to get rid of this positive 3 that I'm looking at right here. And how do we get rid of a positive 3? Well, you know that. We're going to subtract 3 on both sides of the inequality. And 3 minus 3 is 0, so yes, we can cross it out. We bring down a negative 2x. We bring down a less than or equal to. And 11 minus 3, we all know, is 8. Okay, and now we're going to divide by negative 2. You guessed it. And again, guys, I made you divide by a negative. So this less than or equal to symbol is going to again flip to a greater than or equal to symbol. And 8 divided by negative 2 is a negative 4. And so there is our answer. But just like last time, let's plot it. And so negative 4 is on the number line. Right beside it is negative 3, and then a negative 2. And then in the other direction, we would have negative 5 and negative 6. And this time, if we want to talk about the circle first, it is greater than or equal to, keyword or equal to. And so when we plot it, we are going to draw a closed circle, okay? And then what does this say again? It says we are greater than. So where are our numbers greater than? Our numbers are greater than negative 4 to the right, okay? So there's another solid example, okay? Let me give you one more example of this, and we'll call it a day. Example 3. Hopefully you're starting to feel confident about this. Solve and graph. Okay, so now let's do 2 parentheses 3x, let's say plus 1, close it, is less than, I don't know, let's do negative 14, okay? And so if we get started with this, I don't know if this is going to turn out pretty or not. I'm making these things up off the top of my head. You and I both know this is clearly the distributive property. And so 2 times 3x is 6x. And 2 times 1 is 2. Bring down your symbol. Bring down your negative 14. And now that looks pretty simple. So in order to isolate x, we need to subtract 2 on both sides, gang. Okay? And so I get 6x. 2 minus 2 is 0, so we cross it out. Is less than negative 16. And now what do? Well, we divide by 6. And this is not going to turn out pretty, but we need to get over it because not all numbers are pretty whole numbers. 6x divided by 6. The 6's are going to cross out or divide out. X is going to be, the question is, do you flip the inequality symbol? And we're looking over here and we see a negative. We don't really know what to do. But guys, the denominator says what we divided by. And we clearly divided by a positive 6. So if we divide by a positive 6, guys, we do not flip the inequality symbol. So the inequality symbol comes down. Negative 16 divided by 6 does not divide evenly, but it does reduce. And y'all were exactly right. It reduces by 2. And so if we reduce that fraction, we get negative 8 over 3. Okay, and so that's our answer. X is less than negative 8 over 3. And now you're low-key freaking out as you're watching this video because I want you to graph one with a fraction. Okay, but, guys, it's okay. Okay, so draw your number line. Put negative 8 over 3 in the middle. Okay, and hopefully you remember that we can convert improper fractions to mixed numbers. And so 3 divides into 8, guys. Okay, 3 divides into 8. 2 times, right? And 2 times 3 is 6, and we get a remainder of 2. You remember that. So this will be 2 and 2/3. So negative 8/3 is the same as negative 2 and 2/3. Why am I doing that? Because if this is negative 2 and 2/3, gang, then the number to the side of it is negative 2 and negative 1. And then we've got negative 3 and negative 4. For those of you that are low-key still scared of fractions, negative 8/3, I promise you, is in between negative 2 and negative 3. Okay? So our number line is there. But what I really want you to focus on is this symbol here. Okay? So take a look here. The symbol is less than. So you got it. When we graph less than, we graph a open circle. And then it says less than. So the numbers less than negative 8/3 are the numbers to the left. And so we have an inequality. Okay? So those are 3 really good examples. And now that I have skimmed over my Math Labs PowerPoint that you're looking at, or you hopefully have looked at, I need to teach you about compound inequalities. So compound inequalities, and then we'll be done, is literally when we have 2 inequality symbols. So just like we have compound sentences in English class, like we have compound sentences in math class. So here's an example. Negative 2 is less than x, which is less than 1. So negative 2 is less than x, which is less than 1 is how we would read that, guys. And an easier way to kind of think about it is thinking that x is in between negative 2 and 1. Okay? So negative 2 is the smallest I can be. 1 is the most I can be. And so they don't ask you to solve them in this lesson, but they do ask you to graph them. So if you were to graph negative 2 is less than x, which is less than 1, if I go ahead and draw the number line, and the numbers that this inequality is focusing on is negative 2 and positive 1. So I'm going to go negative 2, negative 1, 0, 1. And if you want to, you can go a little bit further. There'd be a 2 and a 3. And on the other side, there'd be a negative 3. Nothing fancy, just want you to see it. Okay, take a look here. Negative 2 goes with the less than sign. Less than is an open circle. So I'm going to put an open circle at negative 2. 1 also has a less than sign. So again, I'm going to put an open circle at 1. And if you paid attention to what I said earlier, I know I said negative 2 is less than x, which is less than 1. However, I also said x is in between negative 2 and 1, which means everything in between negative 2 and 1. Okay? And so last but not least, I have seen my math lab say this. Graph negative 2 is less than or equal to, or is less than, let's do an equal to like I said. It's less than or equal to x, which is less than or equal to 1. But it gives you the stipulation where x is an integer. Okay. There is a key. Okay, where x is an integer. So let's graph it. Number line. Again, we're going negative 2, negative 1, 0, 1. And if we continue, we can go a 2 and a 3 again. And we can go again to the negative 3. Here's the thing, though, guys. I have to be... Okay, first off, negative 2 goes with the less than or equal to sign. So it's going to be a closed circle at negative 2. 1 goes with the less than or equal to symbol. So it's going to be another closed circle at 1. But now, instead of drawing a line connecting -2 to 1, x has to be an integer. And in Chapter 5, you learned that integers are positive or negative whole numbers. Okay, you learned that. And so you cannot be in between -2 and -1 because there's a whole bunch of decimals in there. And there's a whole bunch of decimals in between all of these whole numbers. And so what that means is you can only be -2 to 1, integers in between those two numbers. So you can be -1 and you can also be 0. Again, guys, I am not connecting these lines. I'm not connecting the lines here like I did up here because I specifically said x has to be a integer. You said it. Okay? So I hope this lesson was helpful. This is 6.5. Make sure you do your assignment on My Math Lab. Thanks, guys.